Hello students, see here the numerical related to Kirchhoff's first law. How to calculate current I here. Here the point A, this is the junction point, this is B, this is also a junction point, point D, this is also a junction point, point C, this is also a junction point. You know, according to first law, the algebraic sum of current meeting at a point in the electrical circuit or meeting at the junction is 0. You know, delta I is equal to 0. Sorry, sigma I is equal to 0. So here, this is the point A at which this 15 ampere current meet and 8 ampere outgoing, and you don't know what is the current going to the junction B. So here, very easily you can calculate 15 minus 8, that is 7 ampere. So this is the 7 ampere current. 7 ampere current reaches the point B. Clear? At the junction point, at the junction B, 7 ampere coming, incoming current, 3 ampere incoming, and this is IB said, this is outgoing. So here, when you use junction rule at the point B, this is 7 ampere plus 3 ampere minus IB is equal to 0. So IB is equal to 10 ampere. So here this will be 10 ampere. Clear? Now at the junction D, this is 8 ampere current and this is 5 ampere current at D. At the junction D, that is 8 ampere incoming, this is 5 ampere incoming, and this is ID outgoing, that is 0. So here ID is equal to 8, 5, 13 ampere. So here very well you know, this is 13 ampere, this is incoming current, and this is 10 ampere, this is incoming current. So here at the point, at the junction point, C, 13 ampere plus 10 ampere minus I is equal to 0. So here I is equal to 23 ampere. So these types of numerical, to solve them, use the first law of Kirchhoff here. And please remember, incoming currents are counted positive and outgoing currents are counted negative. Just like I have completed this one, you can also solve here to calculate 7 ampere here. That is 15 ampere and this is outgoing and this is outgoing. Clear? You can calculate it. Now you have a question to solve it. एक क्वेश्चन है जिसको आप लोग स्वयं से सॉल्व करेंगे. That is another question here. This is this one. This is 4 ampere and this is here 2 ampere and this is here 1 ampere. This is here 1.3 ampere, and now you have to calculate I here. So very easily, this is a junction point, this is a junction point, and this is also a junction point. At this point 4 ampere, 2 ampere current, that is incoming. So outgoing will be how much? 4 plus 2, that is 6 ampere. So 6 ampere current is meeting at the junction point Q. And here this 6 ampere is incoming and 1 ampere, that is outgoing. 1 ampere is outgoing, that means 6 ampere minus 1 ampere, that means this is 5 ampere. So 5 ampere current will reach at the junction R, and here 5 ampere, this is 1.3 ampere, that is outgoing, this is also outgoing. So 5 ampere minus 1.3 ampere minus I equal to 0. So this becomes 3.7 minus I equal to 0. So this is I equal to 3.7 ampere. So you can easily solve these numericals. So you try. If any problem, ask myself. and related to second law raised question I will give in next video. Thank you.